So now we're going to start the actual problems. We are going to look at the titration of a weak acid with a strong base, and the problem at hand is calculating the pH at the different points when we do a titration of 40 milliliters of 0.150 molar barbituric acid with potassium hydroxide. The Ka is provided, and we're going to have different amounts of KOH added. So where we're going to begin is no KOH added. So this is going to be our standard ice table. I'm going to represent our acid as just HA, and then that is going to be added to water to give us H3O plus and A minus. Another way you can write this simply is just HA going to H plus and A minus. H3O plus and H plus are essentially the same thing when we write it out. So we're going to start with 0.150 molar HA, no acid, no conjugate base. That is our initial concentration. The change is going to be minus X, X, and X. Because we're starting with no products, the equilibrium is going to push us towards the products at this point. And then at equilibrium, we would have 0.150 minus X, X, and X. Remember the equilibrium constant Ka is equal to the H plus or H3O plus concentration times the A minus concentration all over the HA concentration. So we know Ka, it is provided, and H3O plus and A minus are both X, and HA is 0.150 minus X. What we can typically do is assume that this X value, when we add or subtract it, is so small, it really doesn't affect our overall value. So we can omit it and just plug in 0.150 for the HA concentration at equilibrium. So what we end up with is Ka, which is 9.8 times 10 to the negative fifth equals x squared over 0.150. So the standard calculation when you're solving for the pH before you add any base is just Ka equals x squared over the initial concentration of the acid. And so the next thing we have to do is solve for x, and after we solve for x, we're going to solve for pH. So when we do the math, if we multiply 0.15 times our Ka and then take the square root, we get x is equal to 0.00383 molar. That is the concentration of our H3O plus and our H minus. Now, again, that is the concentration of our H3O plus. And if we're trying to solve for the pH, we can just do negative log of the H3O plus concentration. So if I do the negative log of 0.00383, what I get is, let's see here, I get an answer of 2.42. So the pH before we add any base is 2.42, which makes sense because we're starting with an acid, so we would expect the pH to be less than 7. Also, if you solve for the pKa, you find it somewhere around 4 point something. We know that before we add any base, the pH should usually be below the pKa value as well. So, to summarize, when we are trying to solve the pH before we add any base in a titration, we just set up our rice table and we use the equilibrium Ka equals x squared over the initial concentration of the acid. We know that x is equal to the H3O plus concentration or the H plus concentration, and we can do negative log of that value to solve for pH. In the next video, we're going to move on to adding 30 milliliters of KOH. Now we're going to have to determine how many moles of each we have and see what's in excess and how much of each component we have after the reaction occurs.